Hello, welcome to the New Stack Makers, a podcast where we talk about at-scale application development, deployment, and management. Chef has been our sponsor for the podcast from ChefConf here in Austin, Texas. Learn more about Habitat, InSpec, and Chef's focus on continuous automation at chef.io. Hey, it's Alex Williams of the New Stack here at ChefConf in Austin, Texas. I'm here with Dominic Richter, who is a product manager for compliance at Chef, and I know he has some other roles. So, Dominic, great to have you here. Maybe you can tell us a little bit about what your overall role is at Chef.
Sure. So, a colleague of mine and me were acquired about 2 years ago by Chef. And we invented what today is called InSpec.
What was the company that was acquired?
The company is called VolcanoSec, written with a U, and we always get a little bit of a confused look, like the Europeans don't know how to spell volcano. It's based on the Greek god Vulcan,
okay.
So VolcanoSec. And back then we invented what today has been known as InSpec, the open source pillar in Chef, and also Chef Compliance.
Great. So, our conversation really is about continuous automation as a theme and how InSpec fits into that. I'm curious about that. So perhaps we can start there and just discuss a little bit about that role of continuous automation and how you think of that in the context of InSpec, and perhaps you can, in the process, explain what InSpec is for everyone.
Sure. So about 5 years ago, my colleague that I mentioned before me, we started to work on an automation scheme in the telco space, and we wrote everything in Chef back then. Mm-hmm. And that was great because we put automation into all the services that we are deploying, and when we push the button, they would go out and configure all of those nodes. Problem was, now that you have all of your infrastructure as code, you fall into the programmer's fallacy of saying, it worked on my machine. Mm-hmm. As soon as you go out and you don't test your code, it might not work in production, a few circumstances might change and things will break. And back in the day, we started to then do what every good programmer should do, which is to test their code. And the same holds true for infrastructure automation. And that was the birthplace for InSpec. So originally we were based off the wonderful ServiceSpec project, and we used a similar approach to test out our automation stack. And then we noticed, when the auditors came in and the security people and they gave us their Excel sheets to fill out, we noticed there's something that we could also do in InSpec that we hadn't thought about before, which is security and compliance testing. And the problem with a framework like with the previous frameworks which we have had has always been that they were focused on DevOps, so you write tests that are actually all supposed to succeed. While as in the security space, you'll see that rule sets like CIS are meant to break a number of tests. You get like 30-40% failures and it's still okay. But we needed to add information to that. We needed to communicate to people which tests are actually okay, which tests are critical, which can fail, and how to generate a report from that. And that was the birthplace for InSpec.
Okay. And so tell us about InSpec today.
So InSpec's come a very long way. When we started with InSpec, it was just designed for operating systems, testing whether your Red Hat configuration was doing okay, whether your Windows systems are configured securely. That was really nice. And then we started to extend it. We went into very commonly shared components like web servers, application servers, databases. And today it's basically evolved into this very complex framework that can hit arbitrary platforms, almost arbitrary platforms. We're working towards that at the moment because what we really want to do with InSpec is to natively support everything you have in your fleet, from cloud systems to containers to bare metal systems, from operating systems to databases, or high-level configuration.
What is it doing? Well, tell us about that.
Okay, so InSpec does two things. One, it collects all the information you have from your infrastructure. We'll basically just go in and see how things are configured, how they are running. And two, it gives you a language to write tests on top of that. So you could basically say, based on that information, I want to make sure that certain things are configured in a certain way.
Right.
And you describe that in a very human-readable, super easy language that even auditors understand. Mm-hmm. And that creates a test, and then InSpec goes out there, tests things out, and comes back with the results.
So you have to do a lot of building of the overall platform itself so it actually can read any kind of really environment or workflow that a developer might be working in, correct?
That's right. Similar to like in Chef, when you wanted to add something like a MySQL configuration, you would create a MySQL cookbook. That cookbook would understand how to configure MySQL. In InSpec, it's very similar. We have created so-called resources. Resources make accessing that service really, really easy and expose all of its configuration parameters and anything that you might have running with that service. In the old days, security people went into their systems, they were opening up these very complex configuration files, and then they were looking with a regular expression whether they found that pattern somewhere in that file. The problem with that is that it doesn't always work, and these config files are very complex at times. InSpec hides that complexity from you. It will just give it to you as an object, and you can just say, hey, in my MySQL server, is it actually running with a secure configuration or not?
So tell us about that architecture of InSpec itself and how you were able to abstract that complexity.
Okay, so we did two things with InSpec. One is that we have a library called Train, which is running everything that goes through InSpec. Train stands for Transport Interface. And what Train does for us is a simple helper where you can run InSpec either locally on your machine, or you run it remotely against a machine via SSH, WinRM for Windows, or even a Docker container. It doesn't require anything on that system specifically to be installed, because it translates every control and every test we have for that system. So that's first, the Train library, which helps us transport our intent. And the second thing is, in core InSpec, we've got a collection of resources, the resources that I've just mentioned. So we maintain these as part of the core projects and offer them as an easy way to talk to your infrastructure. And that's really it. It's DSL plus talking to systems plus having an easier abstraction to all of the components that are on that system.
So to add components to the system, is that where you depend on the open source community?
Yeah, we do. Also, we do maintain a number of components ourselves in the core of InSpec, and we have great contributors who help us with that as well. So huge thanks to everybody who has helped at the project. You also have the option, if you want to, let's say you have a very custom service that only you care about and nobody else, and you want to create a resource which understands this service and exposes it to all of your tests. You can do that without adding it to the core of InSpec. You can add it to a so-called profile, which is the objects in which, that's like a collection of tests that you have. So you add it to that profile, and you add support for your custom resource. And then that profile can suddenly test for that resource as well.
Okay, so how does it, how do you, guarantee the security of the platform itself? I guess it's an open source platform, and you're looking and you're doing all the work that you need to make sure that what's been contributed is legit. But what else, what other guarantees do you have to provide there to make sure that people can trust that it's something that, will effectively be able to, look for, be able to accurately find compliance issues and so forth?
Yeah. So first of all, InSpec is really an open source project that's like the motor that's running all of our compliance needs. When you look at the core of InSpec, it's really an engine for testing. Now, when you look into the compliance use case, and I want to go out and I want to test whether my machines are compliant or not, then you have to have a collection of tests. right? These tests will tell you whether, what's good and what's bad,
Right.
essentially. Now, for the good and bad, we have either the commercial product, which we have at Chef, which is Chef Automate, which has a number of these tests, or there's also the open source DevSec project at DevSec.io, and that also has a number of these recommended tests all written in InSpec.
Okay.
So these tests actually have guidelines about what a good configuration looks like. And if you look at what we are doing for the commercial product, for instance, is we are taking all these tests and we're doing a red-green analysis. So we are taking a machine that's misconfigured horribly and running all of the tests, and we want all these to fail. And then we're taking a machine that's nicely configured and running all of these tests, and we want them to succeed. And that way we keep the quality of the tests.
So it's a constant kind of testing in the red-green
Yes.
environment.
You're constantly testing it as you're developing your resources, as you're developing your profiles. Because, let's be honest, this is compliance as code. So as soon as you codify it, I'm getting back to my fallacy in the beginning, I have it like a programmer, I better write some tests for that. If I don't test it out, I might be wrong. You will find a number of official profiles out there that are being used in workplaces right now that have false positives or false negatives as well, and that's a normal thing. And the thing, the way that we improve this is to actually go and test these things out and improve them.
I guess that's the one thing I keep thinking about when I was kind of watching the demos yesterday was like, there's one thing about automation, but what if the automation is inherently wrong, right?
Exactly. So we have been asked, in the very beginning, when we first published InSpec, the question was, is it really attached very, very closely to Chef? And what if Chef is wrong at some point in their automation stack? And the answer has always been no. InSpec is an independent project that we have used both with Chef, with Puppet, with Ansible and SaltStack, or even if you go to your brownfield and you have like the manual automation, like people doing that for you. In those cases, InSpec still works because it's independent of anything else you're running in your automation stack. It's purely there for testing things out.
So, what is the capability that InSpec has so it's human readable?
So the language itself is designed after a very common framework we have in the Ruby world. It's called RSpec. If you write a rule in RSpec, I'll just schematically say you describe a resource and then you say that its characteristics should be in a certain way. That is a very human readable format. Now, traditionally, you would have to do a little bit of Ruby programming to get the information out of the system that you're testing, right? So you would have to, for instance, run commands, digest their output, and then you would describe what that would look like. Now, InSpec takes all of that away and packages into simple resources. And if you now combine that syntax plus the simple resources, you start to describe things like, and I'm going to give you an example, I describe my SSHD configuration, and I want its protocol to equal 2. And that makes it very human readable, that syntax.
Okay. That, so the human readable capabilities of it, how do you optimize that? How do you, what are some of the things you're needing to improve upon to make it more accessible?
That was one of the main questions we asked ourselves when we started all of this. When we came up with the first iterations of InSpec, we basically had a testing language that we then put into the hands of auditors. And the feedback we got back from them was, we are no programmers, I've never done Ruby in my life, why are you putting this in front of me? I don't know Chef, I don't care about any of this. So they didn't feel comfortable with it. So over many iterations, we went through smaller feedback loops, and we then realized where the syntax actually had to evolve so that the core of the language is as simple and as understandable as possible. We had great help from our friends at MITRE to develop some of the meta structure in InSpec, so to describe controls and all of the information that is attached to a control. And with that came the core language that you can now find in InSpec. And anything that's more complicated, like for instance creating custom resources, has been moved to a separate library. So if you, for instance, want to describe a complex new service. You might have a developer on your team that can help you create that resource, while you as an auditor can focus on just writing out the controls. You don't have to care about the programming part that your developer can take care of, while you just care for the tests. And at the end of all of this, it comes together into one profile that you can take out and test things.
So where do you want to, what are the next generations of the language that you're looking to build?
So InSpec, first of all, at the very beginning I explained how it's going for arbitrary platforms.
Right.
We have a couple of improvements in the core of InSpec coming over the next couple of months as we are approaching the next major version of InSpec that will take us to arbitrary platforms that we really want to test out. That's a big thing for us. And if you describe it in this language, it has to be clear, cohesive, people actually have to be able to understand that.
Right.
The second thing is where the core language has to improve. And we have done a number of investigations in the beginning, not just with the auditors, but also with the development community at large, to see what kind of changes need to happen to the core syntax. We know that RSpec is a long established format that is very, very well known, and we believe that we want to improve on that over the course of time. So at the moment we have some internal discussions about where the language should move, what it should look like, without breaking anybody that's out there.
What's the intersection then with Habitat?
Right. So Habitat is here for application automation. Just like Chef is here for the infrastructure automation, Habitat takes care of that. You have the same problem you've always had, which is if you have security people that you want to prove things out to, you have to describe anything that's running in there in a simple syntax that they can describe and just come back with a report. That's what they really need. They have requirements from the payment card industry, from the healthcare industry, and so on. And the format that we gave them with InSpec is to be able to describe all of their requirements in that one simple documented automated format. And then you take that, and with Habitat, which is so awesome at the application automation side, you tie that together and you have your applications that are running continuously being tested against these profiles as well. And that means, and here comes the wonderful thing, as soon as you update anything in the Habitat stack, right, you develop a new version of that application, you change settings, anything like that happens, the InSpec runs, so the test runs get triggered for you across your fleet automatically, and they come back with a report. And that is a very powerful concept. It moves you away from a push model to a model of not to orchestration, but to choreography, where all of these nodes know I've just updated myself, I have also got to test myself.
That choreography then plays into the demo that we saw yesterday, where, like, if, for example, there was the scenario that IT people face all the time. Well, there's an announced exploit, right?
Yeah.
Right. And then they, everyone has to scurry to make sure that everything's patched correctly.
Correct.
Right. How is this philosophically changing the way we think about patches?
So vulnerabilities and patches go hand in hand. When a new vulnerability is released, the most frequent way to actually resolve it is to install a new package update and to patch that. One of the great things we have seen yesterday is if you look into how software is built on those many stack layers, you'll see that the vulnerabilities actually go to a really low layer that can impact multiple packages that you're running out there, from your web servers to your Java applications to something else. One of the great things is that we can test these things out. So with InSpec, again, running through Habitat or running through Chef, we can see these problems by creating a new test. When something like this is released, you create a test that's now available everywhere, that's then reporting back so you can see the failure. And then if you want to remediate that, you get the benefit of just going in and remediating at the core. So instead of, you have, let's say for instance you're building 5 towers. And these towers all start to lean a little bit to the left. The problem with that is if I just go in and I fix every single tower, if I start to build a new tower, that might lean as well, because they all have a fundamental problem, which is the foundation. The foundation doesn't work. So instead, we go in, we fix the foundation, and that fixes the towers as well.
So it can take a lot of work to rebuild a foundation.
Well, it depends on how you optimize your build chain. Like we have seen yesterday, we only rebuilt the core library, so the OpenSSL library. And as soon as that was available, that was one of the building blocks for everything else that was running. So the question is really, yes, it does take a lot of time to rebuild all of these other services that depend on my foundation, because the foundation I'm only building once. So I'm then rebuilding all of the services that depend on that.
Right.
But then again, we have these build cycles optimized so that all of the building blocks that make it in, we have many of them cached anyway. So as you have seen in the demo yesterday, actually, it was way too fast. We ran through the first bit of OpenSSL update within 2 minutes and 30 seconds, and the Nginx update within 40 seconds. So the total cycle time on that was barely 3 minutes and a few seconds.
So the cache, there's a cache that you depend on.
Yeah, there's packages which are already out there.
Yeah.
So you depend on a number of packages which all come together to form your software.
Right.
Right? So if you replace one smaller piece there, it's like in a tree, you're going up that tree, and all the packages that then depend on that small piece get rebuilt.
So so there must be quite a metadata layer here that helps you then look for those commonalities to be able to update these quickly then.
That's right. That's how the mechanism works under the hood.
Right.
We build up this structure and this connection between these packages to know which package influences which other package. And that helps us to then trigger from one point all the way over here to your other package which you need at the end of that run.
That's interesting. So there's a real level of intelligence that you're building in to the algorithm itself to kind of constantly be able to look for new instances of complexities and vulnerabilities that are surfacing in the overall community.
Yeah, so let's separate that. So one layer is in Habitat. So
Right.
Habitat has all
Right.
of that build logic
Right.
to automatically create
Right.
these packages for you. And then the other layer is in InSpec, and InSpec has this wonderful freedom to create all of the controls that you need, both for the configuration side as well as if you're interested in the vulnerability side, to test that out. I still remember one old case when Heartbleed actually hit us.
Yeah.
And I was in the telco space, and we had to go out and actually test all of these machines.
Yeah.
The crazy part is I had to go through multiple networks that were attached to this and see
Right.
where is this thing exposed.
Right.
I didn't even know. Had I had InSpec back in these days, I would have InSpec running on all of my nodes. And the way that I would have done it is basically distribute, like create the new test. InSpec would have pulled that test down, would have tested all of these machines from inside out. I would not have cared about any of the configuration, network stuff, and so on. We've just tested anything that's running and come back with the results. And that's a wonderful thing.
That's a new level of automation. What's the next level of automation in your mind for InSpec?
So the next level of automation will be where InSpec is actually getting connected to some more intelligence and some more automated help to bring information together.
More intelligence then, what do you mean?
I'm alluding a little bit into the direction of artificial intelligence and getting other sources of information in. And that has to do with how the compliance community is evolving. We right now have for the longest time ever, we have had the compliance community very focused on prescribing what you need from your systems, very detailed. Then the other side is now coming in, which does threat intelligence, or also pattern recognition across your infrastructure to see which patterns are healthy and which are not healthy. It's like detecting cancer, good cells versus bad cells. I believe that the right mixture is somewhere in the middle. It's by combining these two mechanisms to describe things, because if you only have the AI mechanism, that might still go wrong. It might go horribly wrong, as we have seen on Wall Street. So there's a few layers which we have to put in that help us prescribe what is going on and couple that with the intelligence that is out there that we can use. Because in the long run, let's be honest, we're getting more data out there, we're getting smaller components, everything is getting massive. And in order to get through that massive pile of information, we will need some help from mechanisms that are in the field of artificial intelligence and learning.
A lot of that will come from the business, correct?
That's right. Yeah.
The processes that the businesses follow, not the developers, and I think now the operations people have set that foundation.
Yep.
But now there may even be need for a new kind of foundation that integrates the information and data from the business side of the organization.
That's right. If you look into many of the requirements that you have out there these days, they're actually describing business processes or how humans actually interact.
Right.
And some of these requirements cannot be easily mapped to the technology that's executing them. But if you see these human beings as actors on that system, these actors have effects. Like every change that they're doing has like a ripple effect throughout your infrastructure. These will become things that we will start to evaluate, and we can then infer what the actors should be doing or should not be doing.
Right.
So you can describe higher level rules that you can right now not automatically test for in your infrastructure, but that will become testable in the future.
Great. Thank you very much for taking some time to talk today. I really appreciate it. It's been real interesting to learn about where you're going with these different things, where you're taking InSpec and how you're thinking about artificial intelligence, which I think could be an entirely other conversation. So we'll have to get together soon, and I have to get together another time, Dominic, to discuss it. Thanks for joining us. Really appreciate it.
You too. It was a pleasure. Thank you.
Chef has been our sponsor for the podcast from ChefConf here in Austin, Texas. Learn more about Habitat, InSpec, and Chef's focus on continuous automation at chef.io. Listen to more episodes of the New Stack Bakers at thenewstack.io/podcast. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.